I can hear you. Yeah.
What about now? Oh, the
Yeah, I
sound.
can.
Okay.
Hey, is this the right meeting?
House. What about now? That's good. Then maybe this one should. It's okay like that, right? Oh, okay. Thank you. Okay, so I want to welcome you to another statistical class. This is confidence interval for population mean. The other time I walk you through confidence interval for proportion. So in the outline today, I'm gonna have a
Hello?
review on confidence interval for proportion, and I'm also gonna have, you know, I'm gonna walk you through sample size determination to estimate population proportion, and after that, we're gonna walk you through interval for confidence interval for mean, and after that, I'm gonna walk you through how do we determine sample size when we want to estimate the mean and proportion. Okay, so let's get started. I first want to have a kind of review on how do we, you know, based on what we did before, confidence interval for proportion. Of course, you know, we normally want to estimate proportion if we're interested in certain characteristics. Okay, for
Professor?
instance, I want to know, the proportion of Americans that approve, the job the president
Hey,
is
no, you
doing,
can't.
or
I joined the old
uh,
meeting room because he never posted a new one. So I
want,
joined the old one. Review and consider for
sorry, give
proportion.
me, give me 1 second. Somebody joined the Zoom. I, this is a class. What are you looking for?
I thought we were having a Zoom session today.
No, no, this is exam. I mean, sorry, this is a class. I'm in a class. I'm
Oh,
just recording. So sorry about that. Somebody joined the Zoom. Okay, so like I said, we we want to estimate the true value of a proportion, and of course, because we are limited by budget, we may not be able to study the entire population. When you study the entire population, that's why you're gonna have opportunity to obtain a true population proportion exactly. And what do we normally do? We take a sample, right? When we take a sample, estimation is involved. Okay, when you take a sample, estimation is involved. Then it means you're actually going to estimate uh, the true value of a proportion. We call that sample proportion. And when you estimate, um, when you have a single value, okay, that's a point estimate, right? And I told you a point estimate could be high or low, which means a point estimate cannot be trusted. When you have a single value that cannot be trusted, and how do I know it cannot be trusted? Is because I was able to know through sampling distribution. Because if different researchers should go into the field and collect the same sample size, they're actually going to have different value for proportion. And that's why we needed what I called interval estimate. I think I justify in the last class that interval estimate is better than having a point estimate. Okay, so we have interval estimates for proportion. I just wanted to take note of that. Okay, and you know, how do we decide? Like, if I want to go out to estimate proportion, for instance, I actually want to go into the population because election is coming. I want to go into the population to take a sample of eligible voters. I want to ask them question who they're going to vote for. How do I decide on the number of sample that I'm actually going to choose, which we call sample size determination. So we don't just choose sample arbitrarily. Okay, there's something that actually going to guide us in doing that. Now, if we want to choose sample, okay, we actually want to choose sample based on high level of confidence. Okay, don't forget when we construct an interval, we can construct interval, we normally, when we construct an interval, we normally associate level of confidence. Okay, so we want a situation whereby the number of sample that we're going to choose, we want to put into consideration high level of confidence. And not only that, we also want to have a small margin of error. So why do I say small margin of error? Because if I have a small margin of error, the interval is actually going to be narrower. We don't want a situation whereby the interval will be wider. Okay, so what could lead to a wider interval is actually when you have a large margin of error. Okay, and let me also tell you this. The margin of error, is a product of the z-score multiplied by the standard error. And it means when the standard error is large, the margin of error is going to be large. Okay? And how can we make a standard error to be small? Because if the margin of error is, if the standard error is small, the margin of error is going to be small. And what can make the standard error to be small is when we consider a very big sample size. And how do I know this? I need you to pay attention. I need you to take a look at that. That is what you see right now is actually, I'll give you 1 second. I think I'm going to write something now. Now, if you take a look at this, that is the formula for margin of error. And if you look at the other part, square root of something, that's a standard error. If I want a smaller standard error, the sample size has to be large. You see n in the denominator. Okay, when you have a fraction and the denominator is very big, you expect the whole fraction to be small. So what could guarantee a smaller standard error is when you have a large sample size. And the moment you have a smaller standard error, you're obviously going to have a smaller margin of error. And the moment you have a smaller margin of error, your interval is going to be narrower. Okay. Now, I want to walk you through the example now. Recall that in the 2012 resident satisfaction survey, the city of Minneapolis find out that 32% of the residents felt that public safety is among the biggest challenges of the city in the next 5 years. However, suppose we want to obtain a more recent estimate of P. Now, in the other question that we did for 2012, they have an estimate, the 32% as a P cap. And let me tell you this, data do expire. So can we have a way to estimate what the recent proportion is going to be, and in such a way that, we want to estimate the true proportion of Minneapolis residents who felt that the public safety is among the biggest challenges of the city in the next 5 years. And the question now, how many people do we need to pull in order to estimate P within 3 percentage points with 95% confidence? Now, it means they're giving you the margin of error. The margin of error, you want to restrict that to within 3%. And right now, your P cap, because the research has been conducted before, you can plug in the P cap. So if you take a look at what I'm doing here, so from the old survey conducted, we have a P cap of 0.32. We're going to plug that in. And when we plug that in, the level of significance here is 95%. That's why you have 1.96. At the end of the day, you got 928.81 that we always round up. So it means if you actually you want your margin of error to be within 3%, and with a 95% level of confidence, you should be ready to take a sample of 929. So that is what that means. Now, what I'm gonna show you right now, if you actually so that is 9. Now, what if in a situation whereby no study is available? You know, I told you when the study is available, you're gonna make use of the pickup from the study. But what if in a situation where study is not available, then you're gonna use P to be 0.5. Because why am I using P to be 0.5? Because if you look at the standard error formula, okay, in the standard error formula, you see P into 1 minus P. It is only when P is equal to 0.5, because we want to consider the worst scenario. When P is not available, we're going to consider the worst scenario. What is the worst scenario? The worst scenario is when you have a very huge standard error and you have a very huge margin of error. And in that situation, where you can have the worst scenario is when P equal to 0.5. If you take a look at the height of this curve, don't forget the total area under a curve is 1. The half, the center is actually going to be 0.5. That's going to be the worst scenario. Now, this is the formula right now. Okay, if you want to estimate a proportion, and you actually you want to estimate a proportion, and you want to decide what would be the number of sample that is needed. Your P is, you need to check a related literature to see whether a research has been done in that area before. What did they get as P? Okay, if it is available, you're going to plug it. And that was why I said P star is based on other information, all our past experience. And if it is not available, you're actually going to put a 0.5 as a reasonable guess. Now, you know what I want to do, demonstrate to you now. Go ahead. What is what? No, M is the margin of error. Yeah, M in the picture. Take a look at that. M here, it represents margin of error. Does that make sense? Okay. Now, you know, let's say for this, we want to conduct a study. When P is available, the sample size that you need will be smaller than when P is not available. So which means if going by experience, past experience, or the literature you review, if P is available, that will save you more money. Because don't forget, in research, even though we're looking for 2 things in research: efficiency and reduce cost. Okay. Now, if P is available, okay, the sample you're going to choose will be smaller. And this is how to prove. Let's take a look at this example. A campus group is interested in estimating the proportion of youth students that feel that their binge drinking has negatively impacted their academic performance. How many students should they pull in order to estimate the proportion to within plus or minus 0.05 with 90% confidence? Now, whenever you see plus or minus, whatever value that comes after plus or minus is margin of error. Please take notes. Okay, now you're giving a 90% confidence and you want to find the sample size right now. Of course, with no prior information, what did I say you're going to do? You're going to plug in 0.5 where you see P. That's why I'm plugging in 0.5 right now. Okay, with 90% confidence, the z-score is going to be 1.645. And don't forget the margin of error given is 0.05. I got 270.6, which is approximately 271. Now, if you take a look at question B, based on a UMADD statistics, we expect the proportion to be around 0.25. Now, which means P is available. When P is available and you plug it in, okay, what do you see here? The sample size is 203, which is smaller than when it is not available. And let me also tell you this, whether P is bigger than 0.5 or smaller than 0.5, okay, the sample size is going to be higher. So it's going to be lower. So what I'm trying to say here, when it is 0.5, the sample size will be higher than when it is lower than 0.5 and when it is higher than 0.5. Does that make sense? That's what it means. And that's a worst scenario. Okay. Now, I want to introduce you to confidence interval for mean. We're done with the confidence interval for proportion. Now, let me tell you this. When we want to talk about parameter, we have to, parameter of interest that we may want to estimate, maybe proportion, maybe mean. The one we actually completed now is proportion. Now, if I'm interested in maybe what is the average household income in a particular country, then I'm interested in population mean. If I'm interested in what is the average hours students of this university commit to studying in a week, so the parameter is population mean. But you know what? We don't have resources to study everybody, and because of that, we're not likely going to compute population mean exactly. And what are we going to do? We're going to take a sample, just like the same way we did when we're estimating proportion. And when you take a sample, of course, your estimation is involved. Okay, when you take a sample, estimation is involved. And if estimation is involved when you take a sample, okay, now let's say you want to find the average. You already know the formula for average, which is going to be summation S divided by N, okay? Summation X divided by N, okay? Now, let's say I find my average, and let me just assume my average is 60,000, okay? Maybe I'm trying to look at the average household income, and I got 60,000, okay? This formula here, the formula that gave us that is estimator. I told you on Monday that the value that you got 60,000 is an estimate because we got a single value. It could be wrong or right, just like the way we have in the point, for proportion as well. Now, if this is going to be wrong or right, because if I ask every one of you to go into those who have income in the United States or whatever, or whichever country you want to conduct investigation from, and I ask you to take a sample of 50 and you find the mean that somebody is going to get is going to be different from the mean every other person is going to get. So, and which means the sampling distribution gives us an opportunity to see how statistic can fluctuate. Okay. And because of that, okay, when you compute the mean, okay, you have a single value, it could be wrong or right. Because of that, we're going to consider interval estimate as well. Now, interval estimate, we incorporate the margin of error, okay, into the picture. And of course, let me tell you this, interval estimate, the formula has not changed. Generally speaking, it is point estimate plus or minus the margin of error. Okay, so it now depends on what you're looking at. If you're looking at the proportion, it's going to be a point estimate of proportion plus or minus the margin of error. Of course, the margin of error for proportion is going to be a z-score multiplied by standard error. And you know the standard error to be the square root of P into 1 minus P over N. But for mean, it's different. And I needed to pay attention now. The point estimate is going to be X bar, but let's take a look at the margin of error. You know, the margin of error supposed to be Z multiplied by the standard error, but the standard error here is different. I need to pay attention to this. You know, in sampling distribution of mean that we did in chapter 7, we're able to, verify that, okay, X bar will follow normal distribution with the population mean mu, and the standard error will be sigma over root n, for sufficiently large sample. And don't forget, we standardize using this. Okay, we're using the idea of chapter 7 now. Okay, now if that is taken, now I actually want to move right now. When you take a look at the formula here, Z, okay, in the formula that you see, Z, when we're trying to standardize X bar, that formula, if you take a look at the sigma is called population standard deviation. Now, in most of the time, it's unknown. I'm going to say that, don't forget, we want to estimate the mean. Since mean is unknown, the standard deviation is unknown too. So if it is unknown, what we can do, we can replace sample standard deviation, okay, with the population standard deviation. But let me tell you this, replacing, so X here means sample standard deviation. Replacing sample standard deviation with the population standard deviation, we're no longer going to have a Z-score anymore. Okay, instead of also have a Z-score, it's going to be a T-score. You can see the story now. Initially, which means when the population standard deviation is known, I'm actually going to use a Z. But when the population standard deviation is unknown, I'm going to use a T-score. Okay? And when I'm using a T-score, the distribution is not going to be normal anymore. We're going to have a distribution called T distribution. That was why I said T does not have a normal distribution. But let me tell you this. The beauty is this. If the sample size increases, T distribution behave like a normal distribution. Okay? Now, I need you to pay attention now. Okay, so the T distribution now, okay? Now, in a normal distribution, we got two parameters, mean and standard deviation. But for T distribution, the parameter is degree of freedom. I'm seeing a lot of midterm 2 questions, multiple choice at times may be tricky. And that's why I needed to pay attention in class. I just said something now. I said parameters of a normal distribution, mean and standard deviation. But parameter for T distribution is degree of freedom. And what do we call the degree of freedom? The degree of freedom is sample size minus 1. The degree of freedom actually means the number of independent pieces of information in the data. I'm going to say that again. If I have a sample size n, the number of pieces of information will be n minus 1. Does that make sense? That's what we call degree of freedom. Now, this is the shape of a T distribution. It's looking like a normal, but I'm going to tell you the difference between T distribution and normal. The similarity that it has with normal is it's a bell shape, it is symmetric, but it has a fatter tail. Okay, and the fatter tail means it's more spread out. But what can we do? If we want it to behave like a normal, okay, it's more spread out. If we want it to shrinking, then we're going to take a large sample size. Does that make sense? So when the sample size increases, the degree of freedom also increases. Because the degree of freedom is sample size minus 1. Imagine if sample size is so huge, there's not going to be any appreciable difference between the degree of freedom and the sample size. And you know what? It's no longer going to spread out anymore. It's going to shrink in. Okay? Okay. Now, because of the fact that we're going to be working with, the other time when you want to compute confidence interval estimate, you need a margin of error. If you want to compute the margin of error, you need a z-score multiplied by the standard error in the case of proportion. And for us to get a z-score, we were using Q-norm. But right now, we are no longer talking about z-score. We want to talk about t-score. Therefore, instead of using Q-norm, we're going to be using Qt. Now, I need you to pay attention now to what I want to explain right now. Take a look at this guy. Now, if the degree of freedom equal to 11, find the value of t, that is, we want to get a t-score, for which probability t11 greater or equal to t equal to 0.005. Now, what sign? You see a greater than sign, right? Now, if I want to do this in R, I'm actually going to write Qt. If I want to get a t-score, I'm going to write a Qt. If I want to get a z-score, it's going to be a Q-norm. Okay, Qt, I'm going to indicate that, then I'm going to put degree of freedom. Okay, degree of freedom is 11, that's why you see t subscript 11. Okay, then I'm going to write lower equal to f. F means false. Okay, because the sign is greater than, and that's why I said lower equal to f. Now, in another question, so the t-score now give us 3.010587. In another question, if the degree of freedom is 21, find the values of t for which t21 less or equal to t equal to 0.99. Right now, what is the sign? The sign is less than. I can just write Qt 0.99 degree of freedom equal 21. And that's going to give me 2.517648. Very easy to figure out a t-score. Okay, now take a look at this. If the degree of freedom equal to 14, what is the probability of a t14 greater or equal to 2? I want to find this using R. I needed to pay attention. I needed to look at the board. Okay, now if I want to find that, I'm going to write PT. Now, let me tell you this. There's a difference between getting a t-score and getting a probability with a t-score. The other time, if I want to get probability in a normal distribution, what do I normally do? P-norm. If I want to get probability with t distribution, it's going to be PT. If I want to get a z-score, it's going to be Q-norm. If I want to get a t-score, it's going to be Qt. Does that make sense? Right now, I want to find probability. If you take a look at the question here, if degree of freedom is 14, what is the probability of t14 greater? Because I want to find probability, is going to be PT in R. So PT equal, I'm going to put to df equal to 14 lower equal to f. Why do I put lower equal to f? Because of greater than. F means false. Okay, we're telling you, oh, it is not lower. Because if it is less than, of course, the lower is going to be equal to true. Or you don't write that. Okay, so I just wanted to take note of that. But you know what? When you go to this now, when the degree of freedom is so huge, we expect T to behave like a normal. Okay. Now, I needed to pay attention now. How do we construct an interval for mean? Okay. Constructing an interval for mean, we got assumptions. Number one, randomness. And what do I mean by randomness? It means the way you're going to choose your sample, you must give equal chance to everyone in the population. You're choosing randomly. Okay. Number two assumption is normality. The population distribution you're choosing from has to be normal. And if it is not normal, you need to choose a large sample size. And how large is a large? It has to be at least 30. Does that make sense? Now, if I want to construct an interval now for mean, this is the formula. Now I need you to pay attention. X bar is a point estimate, plus or minus t-score, the t-score that I check from the, using R, multiplied by what is S over square root of N. That's a standard error. A standard error. We normally use sigma, right? Sigma over square root of N, but the population sigma is unknown. And that's why we're using a sample standard deviation. Okay. The same thing that we notice in proportion, margin of error increases, okay, as the confidence level increases, just as the same. So the level is also the same thing is also applicable here. Okay, when the margin of error decreases, when sample size increases, the margin of error goes down. And when the margin of error goes down, we're actually going to have a narrower interval. So just the same as what we notice in proportion. Now, I need you to pay attention now. This is an arrow code. I have data set. Okay, a survey of 51 current adult smokers in the United States asks, on average, how many cigarettes do you smoke per day? Okay, they ask some people, 51 people. The first person said 1. You see the data here, right? You see the data here, right? The first person said 1, last person 3, even somebody said 40. Okay, now we have the data set now. This is data set. This is what we got, from 51 respondents. Now, we want to have the idea of the distribution, because for you to actually use, for you to create a valid interval estimate when you are working with the mean, the distribution has to be normal. And what are you doing here? You're doing a stem and leaf plot, right? You remember what we did? Stem and leaf plot is one of the way. So if you take a look at this now, this is approximately normal. Okay. If it is approximately normal, we can use R to get the mean. When I write MEAN of the data, I'm going to get my mean. SD into the data, you get the standard deviation. Then the sample size length into that, you're going to get the sample size, 51. All what you just need to do is to start plugging them into here. And you need to get your T. Now, remember what we did. If you take a look at this guy, how am I going to get that? You remember the other time, okay? When sample size is 51, degree of freedom will be 50. So the degree of freedom is sample size minus 1. Now, I'm going to use a QT code to get a T-score for this value. I showed you the other time. When I use that, I'm going to use it to multiply this. I'm going to get the margin error of 3.3, and at the end of the day, this is my interval. Now, if I have that as interval, I want to interpret that. Then I need to put into consideration the confidence level. Okay? I need to put into consideration. Now, another thing I needed to know here. C. Okay. 1. T alpha over 2. T alpha over 2, comma, N minus 1. Let's take a look at something here. Okay, so when the level of confidence is 99%, what is alpha? Alpha will be 1%. Well, 1% is 0.01. Divide the 0.01 by 2. That will give you this, 0.005. You see that? And by the time you follow what I did the other time for QT, you're actually going to get that particular value. Now, if I want to interpret right now, we are 99% confident that the average number of cigarettes that a smoker has each day is between this and this. It is more safer to report interval estimate than reporting just, 19.1 is a point estimate here, right? So because 19.1, that is a point estimate here, could be too high or too low, and that is, it cannot be trusted, it's not reliable, and that is why we incorporate the margin of error. Okay. Now, I'm actually going to move right now. I'm actually going to move right now. Okay, so, but let me tell you this. Go ahead. How do I calculate what? Oh, you come here. Give me 1 second. I think I was showing you something the other time. Do you see? Do you see QT? Oh, sorry. Not this one. Oh, how do I? Oh, you mean how I find? So after finding your QT, I'm going to show you something now. Give me 1 second. Now, what is X bar? 19.1. Look at the code, the mean of your data. You can, in R, you just write MEAN of the variable is going to give you the mean. So I got it. So that is what I put here. Do you see this guy here? That is the code in R. Okay. I got my mean from the data set because we're giving the data set. Look at the data set. You see the old data set, you get the mean, you get the standard deviation. Okay. So the moment you get all of that, then you start plugging in into the formula. So the mean is going to be that. This is the formula, this standard deviation plugin, the sample size. This is the one that I said we're going to compute using QT. That makes sense now, right? Okay, now I want to move. But you know what? If you don't want to go through all those stress, please, I need you to listen now. We can just write just simple code. We're going to have all of them computed. Are you ready? Are you ready? Please pay attention now. Now, what is the name of my data? When you say the data is what? CIGS, right? You save your data with CIGS and you want to construct an interval. You want to construct an interval, a simple code. If you don't want to go through all this stress, write t.test. Do you see this? Look at this code. Give me 1 second. Do you see this code? If you write t.test, the name of your data, you indicate the confidence. You know they say 99. If they say 95, you change it to 0.95. Then alternative, you're going to write two-sided. Why do you say two-sided? You don't forget we have a plus or minus, right? Then with that, you're going to see all these results. This is the output that Arrow is going to give you. And there's a lot in this output, but where is the confidence interval? I'm going to show you now. Oh my God, this is the confidence interval. You see the lower and the upper? That is the same thing that we got the other time when you compute it manually. Using R, it's very, very easy. So that's a straightforward code. T.test into whatever you use to save your data with, the confidence level indicated, alternative, always two-sided when you are constructing interval. So when you take a look at that guy now, okay, if you take a look at what we got, 15 point something, you're going to see that is the same as what we got here. When you were, this is like a waste of time. This is a waste of time. So with a simple code, t.test, you're actually going to have everything computed. But you know what? There's a lot of information here. But for now, what you need is just that. Yeah, go ahead. Yeah. Okay, that's a very good question. If the population is for both t-test and z-test, for Z and T, the population has to be normal. If the population is not normal, they take a large sample size. And how large is a large? It's at least 30. Does that make sense? Okay. Now, okay. Oh, I think I repeated that, so I'm done with that. Let me move. Okay, I think I'm done with that. Okay, this is what you just talked about. Okay, so robustness of T procedure. Okay, it's robust to non-normality. Like if population is not normal, but if you choose a large sample size, you stay fine. Okay, then does not perform well if there are outliers. It doesn't perform well. Then it's not robust to violation of the assumption of a random sample, which means you have to choose random sample. Does that make sense? You have to choose random sample. Lastly today, sample size determination when I want to figure out average. I think I've shown you sample size determination when you want to figure out proportion. We also have a formula for that. Like for instance, I want to know the average number of hours students in this university committed to study in per week. And how do I decide on the number of students to investigate? Okay, I want to figure out me, but how do I know the sample? How do I determine the sample size? I need to pay attention. This is the formula here. Okay, this is the formula right now. Okay, N has to be greater or equal to T score. Okay, T score, standard deviation divided by margin of error or squared. Okay, so take a look at that. Now, if you take a look at what you have here, I said, you can see that here there's a Z, right? In the other one, there's a T. I'm going to show you again. Take a look at that. There's a T here, okay? And here, there is a Z, okay? Because we normally want to choose a very large sample size, okay? So it doesn't really matter. But this is the situation. I said, where S is the estimate of the standard deviation based on other information or past experience. Situation where here, if I can have a population standard deviation in existence, I'm going to use Z. Okay. But if I want to use a sample standard deviation, okay, then I'm going to use Z. Okay. So take a look at that. Now I'm going to walk you through example right now. Okay. I needed to take a look at this example. Suppose the Minnesota Wildlife Service wishes to estimate the mean number of days spent hunting per hunter for all licensed hunters in Minnesota. Okay. Now, all licensed hunters in Minnesota is population size. We don't have resources to study all of them. We want to take a sample of them. We now want to decide, okay, statistically, what would be the reasonable number of sample? Now, how many hunters must they survey in order to be 95% confident that their estimate is within 1 day of the true mean? Within 1 day of the true mean. That's a margin. Okay? Use the fact that for a previous study, I told you, a previous study conducted in year 2000, the sample standard deviation was 10. The standard deviation was 10. Now, you remember the other time when I was talking about sample size determination for proportion, I said when P is available, you use the value that's available. If it is not, use 0.5. Now, in the case of when you want to estimate the mean, okay, and you want to figure out the sample size, if the standard deviation from previous study is available, you're actually going to use the formula that have a Z-score. It's going to be this one, which means your Z, you want to get it, you need a Q norm. But what if there's no prior information about that, and you want to use sample standard deviation? It's going to be a T-score. Okay? But right now in this question, In this question, it's available. Then I'm going to use a z-score. And don't forget, a z-score for 95% confidence level is 1.96. Okay. Now, the margin of error is 1. Okay. And don't forget, by the time I put that, I got 384.16, which we always round it up. It's going to be 385. What am I trying to tell the world? If they want to have a margin of error within 1 day and with a level of confidence of 95%, they should be ready to investigate 385 hunters. Is there any question on this? Now, actually, going to say this is the end of chapter 8. Now, let me prepare your mind. In the meantime, one result will be uploaded next week. Okay. And we started counting down to midterm 2. Now, chapter 1 to 6 is not going to be part of midterm 2. So midterm 2 start from chapter 7, chapter 8, and so on. Midterm 2 is not going to be cumulative, but final exam is cumulative. Does that make sense? Okay. Make sure you all stay safe and have a lovely weekend. Bye for now, everyone. Yeah, you can. Yeah.
Notice for the slideshow. I think
Oh, okay. I will upload that. Because I think, I don't know, virus attacked that. And that was why I was not able to project it maximally.
okay.
But I'm gonna update that.
Can you like scroll up the slides? Because I saw that like some of it was starting to like check off.
Oh, yeah. I don't know. So what happened?
I don't
Like
know why
it,
it's
you
like
see?
that. Yeah.
So that was why if I make that projection, it's gonna disappear.
Okay.
But I will edit that.
Okay. Thank you.
Yeah, you're welcome.